the Arduino starter kit. We've decided to purchase a starter kit which has a whole load of different sensors for the Arduino.
Yeah, great.
It includes a Mega control board. This is an Arduino Mega control board, and a whole load of sensors. It's got more than 300 components in it. And it also has an online tutorial with 73 projects in it. This is what it looks like. This is our box which has it in, which needs a bit of pushing, and all the components are in there. We purchased that in August, and it's going to be available for loan to members. We'll talk about the loan process a little bit later. So these are all the components that are included in there. The documentation, which is at this location here, has got all sorts of bits and pieces. It starts off with the description of each of the components, what the theory behind it is, how it works, etc. And most importantly, if you want to buy them, where you can source these particular components. So that's pretty good as a sort of reference for the components. Then it's got a bit about installing the Arduino development kit, and some introduction stuff to the Arduino before it gets into some projects. This is the very first project. This is about how to digitally write on the board, get the board to write. It's also got projects for most of the components. They have their own little project on to show you how to use them. So in order to start up, you need to install the Arduino IDE. This is the location for that, and you obviously just click download and then go through the install process. Once you've done that, you get this icon on your desktop, the Arduino IDE, and when you click on it, it starts up the Arduino IDE. Now, just to show you that, there's my icon on the desktop. Double click on that, and it runs up the Arduino IDE. Now what I've done here is I've loaded up the example, which is that first example about how to flash the LEDs. What happens is if you have a look here, you see that if I pull down on this, it says no board selected essentially. When I push that into there and put that on there, so it's connected up to the Arduino. Oh, the Arduino is trying to wander across. This cable is nice and thick. And you see that now we've got the Arduino Mega or Mega 2 as selected as the Arduino. And what I'm going to do is I'm going to go back to this, and we're going to do this particular project. So we just plug that into there. This is the project we're going to do. This is that first example. We got the LED, the longer pin goes to that side.
So these are all push fit, no soldering.
Push fit into the breadboard, and then we've got the resistor. We're just going to put from the longer pin there to the pin over there, and I'm going to take one of these and go from ground, which is that one, to the side of the LED. I'm going to take this one and go from pin 9 to the other side of the resistor. Oh, okay. It's running it for some reason. Okay, Alt tab. I want to go to that one. So if I now say upload that to the Arduino, you can see it's compiling it and it's uploading it. Okay. Don't know why. It's pretty weedy. I think that might not be ground. It might be that that one's ground. That's better. I put the pin in the wrong place. So there we go. What it does is it defines pin 9, which is this pin I got plugged in here, as an output, and then infinitely it goes through and writes out a high to pin 9, delays for 1,000, which is a second, then puts a low on pin 9 and delays for 1,000. And repeat and repeat and repeat. Okay.
What language is it using?
This is in C.
Or a variation anyway, isn't it?
It's actually
Scratch, isn't it?
no, it's not
Oh,
Scratch. Scratch is a graphical language that you get modules and bolt them together.
Oh, of course it is,
Yeah. So no, this is C++-ish, but treated as C. Okay, and so there we go. That's that example, and that's what it looks like in practice. It's just to show I can do it in blue or in yellow.
Can you do it in red as well?
I could do it in red as well. Okay, so the other thing I'm going to do is I'm going to use the ultrasonic rangefinder. So in order to find that, I look on my little map and I see that the ultrasonic ranging is in that slot just there, which is that slot just there. And if I have a look, you see that this, open the anti-static bag. You see that this is, okay.
The instructions how to get out of the bag.
Yeah, frustrating cutting open.
By flattening it, is it?
There we go. And I think the pins just caught a bit. You see that that is the thing that they're showing us up there. So what I'm going to do is I'm going to plug that in to 4 other pins just there. Now, of course, remember that it's facing towards you guys, so the pins are the reverse of what they're shown is here. So first pin we've got is ground. Well, I've got this ground on the LED, so I'm going to take that and plug that into the first pin. And the 4th pin is the 5 volts. So I'm going to get a red one, plug that in there, and go to the 5 volts. Sorry, I'm a bit short-sighted. I think that's the 5 volts. 1, 2, 3, 4, 5. Yeah, pretty sure that's 5 volts. And then the blue pin goes from the pin 5 which is showing us being that one. No, the blue pin goes from pin 4, not pin 5, to this is where we get an interesting one.
It's supposed to emit smoke.
To that one, and the green one goes from pin 5 to that one.
Just confirm you could do all of this with the Arduino powered up.
You shouldn't do, but you should power it down, but you know, I'm just risking it.
Don't do this at home.
Don't do this at home.
So all
Okay.
the sample codes available on their website then?
On their website, they list, they not only do they list the codes, in fact, let me show you that.
Great documentation.
Here you go, using the components. They got a picture of what bits you need, a picture of how you label the circuit up, and a logical diagram of the circuit. Here's the example code. Here's a description for all that code, what it does. And here's obviously a picture showing what it looks like when you wired it up.
And can you download the code as well? Does it have a link?
Yeah, you can just highlight it and cut and paste it.
Well, it's got a.
Oh, you've got a copy thing.
It's got a copy thing on it already. So, so where were we? We were here, and if I go to there, I have this. If I do File, Open Recent, Ultrasonic. There you go. You see, this is basically the same piece of code. Now this does a couple of bits and pieces. So, excuse me. One of the things it does is it opens up what's a serial thing, and that's if the serial thing is this thing here. Okay. And so when we do that, there you go. It compiles it, and then it runs the stray. Stray 302. What's that? There it is. It's because I didn't turn it off. Okay.
Okay, so take two.
So now it's running this particular piece of code. What this code does is it uses the serial thing, which is up here, serial monitor. There we go. And what it's doing is it does a read sensor data. It does a read sensor data, and then it uses the distance from that and prints it onto the serial port. So there we go. If we put the hand just there, it's 3 centimeters, it's 7 centimeters, it's 11 centimeters. So it's using the thing to measure the distance to my hand. Okay.
So what's it bouncing off there?
So there's an ultrasonic speaker and an ultrasonic microphone, and it sends out a pulse on that, listens for the reply, and then takes the time that it takes. So it does the delay in microseconds. Sorry, there you go. It does the digital write high and then low, and then measures how long the pulse takes to get back, and multiplies it by 50. Because
Whatever reason.
because speed of sound. Because the speed of sound is 340 meters per second.
Okay.
So it has to be 50, obviously. Okay, let us.
It's 58, not 50.
So can we
You're
ask
right,
it
it's
to do
58.
something else, like if it senses something, so we can ask it to maybe move.
What we can do is do something else. Okay, so if we
Using a robot, it would stop the robot from hitting the wall, or at least make it slow down before it hits the wall.
so I did
Total range, 5 inches.
5-10 inches, yeah. what I'm going to do is say, let's open this one. I guess I need to shut this one and then compile this one. There we go. Now what this one does is it combines the two examples we've just seen, right? So it's flashing this thing at a certain speed, and it's measuring the ultrasonic distance. But what it does is it leaves it, here we go, it leaves it high for a time that depends on the distance that it measured.
Oh, right.
So if I put that there, it flashes the yellow light fast, and if I put it there, it flashes it slow.
Now, I don't want to spoil your thunder, but there's the next project including audio.
So, but the reason why I wanted to do these three examples is because obviously two of them come straight from the documentation.
Right.
And then this is a simple example where we're basically taking two different projects and we're combining them together in some way.
And effectively creating a reversing circuit.
And effectively creating a reversing circuit. Exactly. Exactly. Okay. So just as an example of the sorts of things you can do. So in the thing here, you see the stuff in blue is the stuff that came from the first example. The stuff in red is the stuff that came from the second example. And the stuff in green is stuff that we've put in to stitch the two together.
Yeah.
Okay, so as I said, we have this thing that says where all of the different sensors are. And once you've got a sensor out with its bag, then getting it out of the bag is your own problem.
So does it have the name of the device actually on the base of the
No.
tray? That might be an idea to stop people mixing them up.
No, because when you borrow it, then John is going to check to make sure all the devices are in the right places when they come back.
We'll soon get bored of that.
Why
On,
can't it have a label when you hire it on?
I originally was going to put a little picture of each device in the bottom of the thing,
That would be slick, that.
but the trouble is that this is so deep that you can't actually, it's of no use to you because what we've also got on the back here is something for the devices that basically show you a little picture of the device. This is not, of course, in the order that they are there because there's a whole load of things, there's some slots we've got here that have multiple things in.
Yeah.
And so this is basically, but if you want to know what something looks like, there's the infrared range sensor. And that goes with the kit. Okay, you saw that. And then the other one is the loan process. So when you want to borrow it, you need to talk to John. And you basically have a 2-week window when you can use it. If we go to here, it's under asset loans on Ephesus, and you can see here's a list of all of the devices all the assets that you could borrow. This one we can see has been borrowed by John, and he's returned it today.
Who checks it when he returns it?
I've got to check every single component down to the last resistor.
Did you check yourself to make sure?
I did.
So if there's a theft, no.
Yeah, it's going to be John defrauding the system.
Well, no, I mean,
Okay,
it's the responsibility of
Oh yes.
the person that borrows it to make sure they put everything back in the right slot and that everything goes back.
And no bent pins.
So that's two things.
so that was a relatively short rush through the stuff. Are there any questions?
Do you have a link where we can get our own from?
You just look up our. Yeah, no, we don't.
I mean, kits like that, they're in an abundance, but that doesn't.
But I have seen some dodgy ones as well.
And
It is
more
a-
importantly, it's the
Is there not
documentation's
an
available.
official
is what
Arduino
makes it.
website that you can get info
No,
Probably it's
these
50 times the cost.
no these are from a particular maker. They put it. The Arduino, of course, you can get the Arduinos from the Arduino website, but all of the extra components you can't necessarily get.
But,
It's not like a Raspberry Pi.
Yeah.
yeah. But
I'll ask you again when
it's
I'm
the
on the meeting meetings
documentation
and
that
perhaps
sets
we
this
can find
set
it.
apart because
Yeah.
you can buy them anywhere, these kind of kits, but you know, it's usually dodgy documentation.
Yeah.
That looks
The
really good.
documentation here is actually pretty good.
Yeah.
Oh,
What was the cost of
do your own research to get a
This whole kit was £60.
Yeah, which is very,
So-
very accessible.
So, and we bought this from Amazon. So,
And it includes one mega, does it?
and it includes a Mega. Yeah.
Yeah.
Yeah, the Amazon sell a number of these development kits. I mean, one of the things we've been considering, and we're probably going to discuss on Thursday, is whether we should get the equivalent thing for the ESP32 boards,
Right.
because there's obviously you can get a kit with the ESP32
And
as
then
well.
there's the Pi Pico and stuff like that. And
And the Pis are less
the
wide-ranging peripherals.
Well, I think
Okay.
Arduino is excellent for this low level.
For low-level stuff, yeah.
Pi's are very advanced. It's got some great capabilities, but I think for learning is.
because you can program the Pi Pico with the Arduino IDE.
Oh, of course you can. Yeah.
You just need to download some board mods to it.
Yeah. But
Okay.
No, I've got half a dozen Arduinos and R2D2.
Thank you for your attention.
Thanks, Steve.
Yeah, thanks, Steve.
Okay.
That's excellent. And cut.
And